Tonight, we're going to talk about rain, not as a storm to run from, not as a weather report, but as a quiet physical story. A story of water, air, gravity, heat, clouds, droplets, and the slow circulation of our planet. Rain is one of the most familiar sounds in the world. A soft tapping on a window, a gentle rhythm on rooftops, a whisper through leaves, a steady murmur on streets, fields, rivers, and oceans. For many people, the sound of rain feels calming. It fills the silence, but does not demand attention. It moves, but not too quickly. It changes, but gently. It is both ordinary and beautiful. And behind each raindrop is a long journey. A journey from ocean to sky, from invisible vapor to cloud, from tiny droplets to falling rain, from the air back to the ground, and eventually back to rivers, lakes, soil, plants, and sea. You do not need to memorize any formulas tonight. You do not need to understand every detail at once. Just listen slowly. Let each idea arrive like a raindrop, one at a time, softly, gently. And if you begin to feel sleepy, that is perfectly fine. This story can continue quietly in the background. Rain will still fall. Clouds will still drift. Water will still move through the world in its patient cycle. So take a slow breath. Let your body settle. And let us begin with a simple image. A window at night. The room is dim. Outside, the sky is dark blue. A few soft lights glow in the distance. And on the glass, small drops of rain appear. One drop forms. Then another. A drop slides downward, leaving a thin trail behind it. Another drop joins it. Then another. And soon, the whole window becomes a quiet map of falling water. This small scene is peaceful, but inside it is the physics of an entire planet. The physics of evaporation, the physics of clouds, the physics of droplets, the physics of gravity, the physics of air, the physics of falling, and the physics of return. Tonight, we will follow rain slowly from the surface of the earth, up into the atmosphere and back down again. Before we talk about clouds, vapor, and gravity, let us begin with the sound. Rain has a sound because falling drops strike surfaces. A raindrop touches a leaf, a roof, a window, a puddle, a patch of soil. Vibration, a small movement of air, and those vibrations become sound. A patter, a steady rush. The sound depends on the size of the drops, the surface they strike, and how many are falling at once. Light rain on leaves sounds different from heavy rain on metal. Rain into a pond sounds different from rain on dry earth. This is because every surface responds differently. A leaf bends and flexes. A roof vibrates. A puddle splashes. Soil absorbs. Glass carries sharp little taps. The rain itself becomes a kind of instrument, and the world becomes a body of the instrument. Rain is not just water falling. It is water interacting with air, with gravity, with surfaces, with sound. And perhaps this is one reason rain feels calming. It creates a pattern that is complex, but not harsh, random but steady, detailed but soft. The brain does not need to follow every drop. It can simply rest inside the texture. 1,000 tiny events become one gentle atmosphere. In physics, sound is vibration traveling through a medium, such as air. When a raindrop lands, it shakes the surface slightly. That motion pushes nearby air molecules. Those molecules push others, and a pressure wave travels outward. Eventually, the wave reaches your ear. Your eardrum vibrates. Your brain receives a signal, and you hear rain. This means that even the peaceful sound of rain is a chain of physical events. Falling water, impact, vibration, air pressure waves. A quiet rhythm of cause and response. So before we even look upward to the clouds, rain has already shown us something important. Physics is not only found in equations, it is found in the softness of a rainy evening. Rain falls downward, but its story begins with water moving upward. This upward movement is not usually visible. It happens through evaporation. The surface may look calm, but at the molecular level, it is full of motion. Water molecules are always moving. They vibrate, They slide past one another. They collide. Some move faster than others. At the surface, a few water molecules gain enough energy to escape from the liquid and enter the air as vapor. This is evaporation. The water has not disappeared. It has changed form, from liquid to gas, from visible water to invisible vapor. This can happen from oceans, rivers, lakes, wet soil, puddles, and even from the surfaces of plants. The sun provides much of the energy that powers evaporation. Sunlight warms the surface, escape into the air. So in a very real sense, rain is solar powered. The sun warms the ocean. Water rises invisibly. Clouds form. The motion of water through the atmosphere begins with energy from light. Evaporation also cools the surface it leaves behind. This is because the faster, higher energy molecules are the ones most likely to escape. When they leave, the average energy of the remaining liquid is slightly lower. That means the liquid cools. This is why sweat can cool your body. When sweat evaporates from your skin, it carries energy away. Your skin feels cooler. So the same physical process that helps regulate body temperature also helps move water into the atmosphere. On a planetary scale, evaporation is enormous. Most of this vapor is invisible. You can stand beside the ocean and not see water rising, but it is happening, molecule by molecule, quietly, continuously. The air above the ocean slowly receives water vapor. The atmosphere becomes humid. The invisible begins its journey toward becoming visible. This is the first transformation in the story of rain. Water escapes upward, not as drops, not as mist, but as individual molecules moving freely through the air. Chapter 3, Humidity and Invisible Water. Air can contain water vapor. We call this humidity. Humid air contains more water vapor. Dry air contains less. But water vapor is invisible. This is important. You simply cannot see it. The atmosphere can carry invisible water for long distances. Winds can move moist air from oceans toward land. Warm air can hold more water vapor than cold air. This is because temperature affects how much vapor can remain in the gas phase before condensation begins. When air is warm, water molecules are more likely to remain spread out as vapor. When air cools, the vapor is more likely to gather into tiny liquid droplets or ice crystals. This is one of the keys to cloud formation. Warm air rises. As it cools, it may no longer be able to hold all of its water vapor. Then condensation begins. Invisible water becomes visible. But before we climb into the clouds, let us stay with humidity for a moment. You may have felt humidity on a warm day. Feel damp. Sweat evaporates less easily. When the air is nearly saturated, it cannot easily accept more vapor from your skin, so your body's cooling system becomes less efficient. In dry air, sweat evaporates quickly. In humid air, it lingers. Humidity also changes how weather develops. Alone is not enough. The air must cool. The vapor must condense. Tiny droplets must form, and those droplets must grow large enough to fall. Rain requires a chain of events. It is not simply water appearing in the sky. It is a careful sequence of physical changes. Transport, cooling, condensation, droplet growth, falling. Each step depends on temperature, pressure, motion, and gravity. So a rainy day is not just a gray sky. It is a whole atmosphere in motion, a slow, invisible preparation becoming visible drop by drop. Clouds, we need to understand rising air. Warm air tends to rise because it is less dense than cooler air around it. When air warms, its molecules move more energetically and spread out. The same amount of air takes up more space. So it rises. This is similar, in a gentle way, to how a bubble rises through water. The bubble is less dense than the water around it, so upward it goes. In the atmosphere, warm air can rise from heated ground, warm ocean surfaces, or regions where air is forced upward by mountains or weather systems. As the air rises, something important happens. The pressure around it decreases. Air pressure is lower at higher altitude because there's less air above pressing down. When rising air moves into lower pressure, it expands. And when air expands, it cools. This cooling happens even without the air losing heat to its surroundings in the ordinary way. It cools because expansion uses energy. This process is called adiabatic cooling. The word may sound technical, but the idea can be felt simply. Rising air expands. Expanding air cools. This is one of the central pathways to rain. Let us imagine it slowly. Warm air rests near the surface of the earth. It contains invisible water vapor. The air rises, perhaps because the ground has warmed it, perhaps because wind pushes it up a mountain slope, perhaps because it meets another air mass. As it rises, it enters lower pressure. It expands. It cools. At some point, it becomes cool enough that the water vapor inside it begins to condense, and that is when a cloud begins to appear. The cloud is not smoke. It is not vapor in the strict sense. It is made of tiny liquid droplets or ice crystals suspended in air. The invisible water has become visible. A cloud is the atmosphere showing us where condensation is happening. Clouds are not weightless. They contain water. But the droplets are so tiny and the air current so active that they can remain suspended for a long time. The cloud floats not because gravity is absent, but because the tiny droplets fall very slowly, while moving air carries them upward and around. Stillness, again, can be balance. A cloud is a floating balance between gravity, air motion, condensation, and evaporation. Chapter 5, The Birth of Cloud. A cloud begins when water vapor condenses into tiny droplets or ice crystals. But condensation often needs a surface. In perfectly clean air, water vapor has difficulty forming droplets on its own. In the real atmosphere, there are tiny particles floating everywhere. Dust, sea salt, smoke, pollen, tiny bits of material from soil, oceans, plants, and human activity. These particles can act as cloud condensation nuclei. A nucleus is a little starting point. A droplet begins to form. At first, the droplet is extremely small, far smaller than a raindrop. Many tiny droplets together scatter light, and that scattering makes a cloud visible. This is why clouds often look white. The droplets and ice crystals scatter many wavelengths of sunlight. When the scattering is broad and mixed, the cloud appears white or gray. A cloud is therefore not simply a shape in the sky. It is a population of tiny particles and droplets, a shifting community of water and air, constantly forming, constantly evaporating, constantly changing. Cloud edges can look soft because they are not solid boundaries. At the edge of a cloud, droplets may evaporate back into vapor. Inside the cloud, new droplets may form. Air moves through it. Sunlight shines on it. Temperature changes. So a cloud is less like an object and more like a process. A temporary visible region where the conditions allow water to gather. Different conditions create different cloud shapes. Flat layer clouds, tall towering clouds, wispy high clouds of ice. Storm clouds with dark bases and strong vertical motion. The shape of a cloud tells a story about the atmosphere around it. Stable air tend to create layers. Unstable rising air tend to create towers. Cold upper air can hold ice crystals. Warm low air can hold liquid droplets. A cloud is a visible signature of invisible motion, a record of air rising, cooling, condensing, and shifting. And inside some clouds, the tiny droplets begin a second journey. They begin to grow. If they grow enough, gravity will eventually pull them down as rain. Chapter 6. Different kinds of rain clouds. Not all clouds bring the same kind of rain. Some clouds are thin and high. Some are low and gray. Some drift quietly across the sky. Some rise upward in tall, powerful towers. The shape of a cloud tells us something about the air that formed it. A low, flat cloud often means the air is layered and stable. And rain depends very much on the way air rises, cools, condenses, and moves. One gentle kind of cloud is called stratus. Stratus clouds spread across the sky like a soft blanket. They often create gray, quiet days. Sometimes they bring light rain or drizzle. This kind of rain can feel very calm. Small drops, a steady sky. The word nimbus is connected with rain. Nimbostratus cloud are broad, thick, gray rain clouds. They can cover much of the sky. They often bring steady rain over a wide area, not a sudden violent burst, but a long, patient falling of water, a sky that seems to lower itself gently over the world. Then there are cumulus clouds. These are the puffy, rounded clouds that look like cotton floating in the sky. They form when warm air rises in pockets. Some cumulus clouds remain small and harmless, but if the air is warm, moist, and unstable enough, cumulus clouds can grow taller. They can become towering clouds, and eventually, they may become cumulonimbus clouds. Cumulonimbus clouds are thunderstorm clouds. Inside them, air moves rapidly upward and downward. Lightning may form, thunder may follow. They are part of the atmosphere, releasing energy. For tonight, we can hold them gently in our imagination, not as something frightening, but as a reminder that the sky has many moods. Sometimes it comes from towering columns of rising air. Sometimes it falls as drizzle. Sometimes as a sudden shower. The form of the cloud shapes the character of the rain. Light mist in the morning. Shower. A deep gray storm front. Each one is water returning to earth. But each one carries a different story of air, temperature, motion, and light. Chapter 7. How tiny droplets become raindrops. A cloud droplet is very small, so small that it can remain suspended in moving air. For rain to form, droplets must grow. They can grow in more than one way. One important process is collision and coalescence. Collision means droplets bump into each other. Coalescence means they merge. Droplets are slightly larger than others. Larger droplets fall a little faster than smaller ones. As they fall through the cloud, they can collide with smaller droplets. If they merge, the droplet grows. A larger droplet falls faster. It collects more droplets. It grows more. Eventually, it becomes large enough that upward air motion can no longer keep it suspended. Then it falls as rain. This process is simple in outline, but beautifully complex in detail. Every droplet has a size. Every droplet moves through turbulent air. Some collide, some miss, some merge, some break apart. A cloud is full of tiny chances, and from many tiny interactions, rain emerges. In colder clouds, another process can be important. Ice crystals can grow at the expense of supercooled water droplets. Supercooled water is liquid water that remains liquid even below the usual freezing point because it is not yet frozen. Ice crystals can gather water vapor, grow larger, and eventually fall. As they fall through warmer air, they may melt and become raindrops. This means that some rain begins as snow or ice high in the cloud, then melts before reaching the ground. Rain at the surface can have a cold beginning in the sky. Again, the atmosphere is layered. What falls to the ground is shaped by the temperatures it passes through. If the air remains below freezing all the way down, snow may reach the surface. If snow melts and then refreezes, sleet can form. If liquid drops freeze on contact with cold surfaces, freezing rain can occur. But tonight, we are focusing on rain. Liquid water falling gently through the air. A raindrop begins as something too small to see. The drop begins its downward journey. Chapter 8, the shape of a raindrop. Many people imagine a raindrop as a perfect teardrop shape, pointed at the top, round at the bottom. But real falling raindrops are not shaped like that. Small droplets are nearly spherical. Surface tension pulls the water into a shape with minimal surface area. So tiny droplets are round. As drops grow large and fall faster, air resistance pushes up against them. The bottom of the drop flattens slightly. A medium-sized raindrop can look more like a tiny hamburger bun than a tear. Flat on the bottom, curved on the top. If a drop becomes too large, air pressure can deform it even more. It may become unstable. It can wobble. It can break apart into smaller drops. So raindrops have a natural size limit. They cannot simply grow forever while falling through air. Gravity pulls the drop down. Air resistance pushes against its motion. Surface tension tries to hold it together. The final shape is a balance between these effects. A falling raindrop is a small physics experiment. Gravity, fluid motion, air resistance, surface tension, instability, all in a single drop. Let us picture one slowly. A droplet grows inside a cloud. It becomes heavy enough to fall. At first, it may be nearly round. As it falls, the air below it pushes upward. The underside flattens slightly. The drop wobbles. It may merge with another drop. It may survive long enough to reach a leaf, a roof, a window, or the ground. When it lands, it changes again. It spreads. It sends tiny droplets outward. It may soak into soil. It may join a puddle. It may run down a surface. Falls, changes shape, impacts, merges, flows, and continues. This is the quiet restlessness of water, always changing form, but never truly disappearing. Chapter 9, Terminal Velocity. As a raindrop falls, gravity pulls it downward. At first, the drop speeds up. This is acceleration. But as it moves faster, air resistance increases. The faster the drop falls, the more strongly the air pushes back. Eventually, the downward pull of gravity can be balanced by the upward drag from the air. When that happens, the drop stops accelerating. It continues falling at a steady speed. This speed is called terminal velocity. Terminal velocity does not mean the drop stops falling. It means the drop stops speeding up. It has reached a balance. Gravity pulls down. Air resistance pushes up. The motion becomes steady. Small droplets fall slowly. Larger raindrops fall faster, up to a point. Very large drops often break apart before they can fall much faster. This is why rain can feel gentle. Even though water is falling from clouds high above, a raindrop does not accelerate endlessly. The air slows it. The atmosphere cushions the fall. In a vacuum, without air resistance, a drop would fall very differently. But rain happens in air, and air matters. The atmosphere is not empty space. It is a fluid made of gas. It pushes. It swirls. It carries. This is another example of balance in physics. A falling drop is not simply obeying gravity alone. It is also interacting with the air around it. Gravity tries to increase its speed. A raindrop falling through the atmosphere is therefore a quiet negotiation between Earth pulling downward and air pushing upward, between acceleration and resistance, between motion and balance. When rain falls softly, we are hearing not only water and gravity, but also the atmosphere gently slowing each drop. Chapter 10, Light Rain, Heavy Rain, and Storms. Not all rain feels the same. Sometimes rain is fine and soft, a misty drizzle, tiny droplets hanging almost like breath in the air. Sometimes rain is steady and moderate, a regular tapping on windows, a smooth curtain of water. Sometimes rain is heavy. Large drops strike the ground with force. The sound becomes louder, fuller, more continuous. The difference comes from cloud structure, droplet size, air motion, moisture supply, and temperature. Drizzle often comes from low, layered clouds with small droplets. Rain feels gentle and persistent. Heavier rain often comes from deeper clouds with stronger vertical motion. Air currents can carry droplets upward and downward, allowing more collisions and growth. Thunderstorms are even more energetic. Warm, moist air rises rapidly. Clouds grow tall. Strong updrafts lift droplets and ice particles high into the atmosphere. Inside the cloud, collisions between ice particles, droplets, and air motions can help separate electric charges. This can lead to lightning. Thunder is the sound of air rapidly expanding after lightning heats it intensely. But even storms are part of the same basic water story. Warm, moist air rises. It cools. Water condenses. Droplets and ice grow. Gravity eventually pulls precipitation downward. The difference is intensity. A gentle rain is like a soft conversation. A storm is like the atmosphere speaking with force. For a sleep-friendly video, we do not need to dwell on the violence of storms. Weather is the atmosphere rearranging heat, moisture, and motion. Rain is one way that rearrangement becomes visible and audible. Chapter 11, Why Clouds Turn Gray. On a sunny day, small clouds may look bright white, but rain clouds often look gray or dark. This does not mean the cloud is made of a different kind of water. It usually means a cloud is thicker, deeper, or more filled with droplets. Clouds appear white because tiny water droplets scatter sunlight in many directions. But when a cloud becomes thick, less sunlight passes all the way through it. The upper parts of the cloud may still be bright, but the lower parts receive less light. From the ground, the base looks gray. The thicker the cloud, the darker it may appear. Large rain clouds can contain many droplets and ice particles. Light is scattered and absorbed through layer after layer. By the time it reaches the bottom, much of the brightness has been reduced. So a dark cloud often signals depth and density. A cloud heavy with water. A cloud with strong vertical development. A cloud preparing to release rain. But the darkness of a rain cloud is not only physical, it is emotional too. Humans respond to the sky. Colors soften, shadows fade. The world feels quieter. Sunlight becomes diffuse. Edges become less sharp. This softness can be calming. Less glare, less contrast, more muted color, more gentle sound. The sky becomes a large softbox, spreading light evenly through the clouds. In photography, soft light is valued because it reduces harsh shadows. On rainy days, the atmosphere becomes a natural diffuser. Again, physics shapes feeling. Cloud droplets scatter light. Scattered light changes the landscape. The changed landscape changes how we feel. The science of rain is also, quietly, the science of mood. Chapter 12, Rain, Light, and Rainbows. Rain also changes the way the world looks. It smooths roads. It turns windows into moving patterns. It makes streetlights stretch into soft reflections. And sometimes, when sunlight returns while rain is still falling, it gives us one of the most beautiful optical effects in nature. A rainbow. A rainbow begins with sunlight entering raindrops. White sunlight is made of many colors mixed together. When light enters a raindrop, it slows down and bends. This bending is called refraction. Different colors bend by slightly different amounts. Inside the drop, some of the light reflects from the inner surface. Then it bends again as it leaves the drop. Because each color bends differently, the white sunlight spreads into a band of colors: red, orange, yellow, green, blue, indigo, violet. You see the light coming from many different droplets at just the right angles. This is a quiet and lovely thought. A rainbow is both physical and personal. The exact arc you see belongs to your viewpoint. Rain also creates reflections. A wet road can become a dark mirror. Streetlights become long golden lines. Neon signs blur into color. The world seems double. One city above the surface. One city trembling below it. These reflections happen because water smooths tiny rough surfaces. The result is a softer, more luminous night. Rain does not create light by itself, but it changes how light moves, how it reflects, how it scatters, how it bends. A rainy evening can feel cinematic because physics has changed the behavior of light around you. The same water falling from clouds becomes a lens, a mirror, a diffuser, and a painter of color. This is why rain belongs not only to weather, but also to optics. Every drop can bend light. Every wet streak can reflect it. Every cloud can soften it. And every rainbow is a quiet signature of sunlight passing through falling water. Chapter 13, Raindrops on a Window. Let us return for a moment to the image from the beginning. A window at night. Rain outside. Droplets resting on the glass. Some drops stay nearly still. Some slowly slide downward. Some merge with others and suddenly move faster. A window in the rain is a small world of physics. The drop is pulled downward by gravity, but it does not immediately fall like a stone. It clings to the glass. This is because water interacts with the surface. Water molecules are attracted to one another. This attraction is called cohesion. Water molecules can also be attracted to the glass. This is called adhesion. Cohesion helps the droplet hold together. Adhesion helps it stick to the window. Surface tension gives the droplet its rounded shape. Gravity tries to pull it downward. Friction and adhesion resist the motion. For a while, the drop remains still. Then another small drop joins it. The combined drop is larger. It has more weight. Gravity becomes more effective. Suddenly, the drop begins to slide. It leaves a thin, wet trail behind it. As it moves, it may collect other droplets. It grows heavier. It accelerates slightly. Then perhaps it slows again. The glass is not perfectly smooth. There are tiny imperfections, dust particles, oils, and previous trails of water. All of these affect the motion. This is why raindrops on a window do not move in perfect straight lines. They wander. They pause. They merge. They split. They form delicate paths. If you watch them without trying too hard, their motion can be soothing. There is no single pattern to solve. Just gentle downward movement. A slow negotiation between gravity, surface tension, adhesion, and chance. The window becomes a kind of quiet physics board, not with equations, but with tiny trails of water. Each drop writes its own path, and then disappears into another. Chapter 14, Puddles, Ripples, and Surface Tension. When rain reaches the ground, its story does not end. A drop may land in a puddle. When it strikes the surface, it creates ripples. The drop transfers energy to the water. The surface is disturbed. Waves spread outward in circles. If you have ever watched rain falling into a pond, you've seen many ripples overlapping. One drop creates a circle. Another creates another. The circles expand, cross, and pass through each other. The surface becomes a living pattern. These are surface waves. Gravity and surface tension both help shape them. Surface tension comes from the attraction between water molecules at the surface. It makes the surface behave a little like a stretched skin. Small insects can sometimes stand on water because of surface tension. Tiny droplets beat up on leaves because surface tension pulls them into rounded shapes. When a raindrop hits water, surface tension helps restore the surface after the disturbance. Gravity also pulls raised water back down. Together, gravity and surface tension shape the ripples. The size of the drop, the speed of impact, the depth of the puddle, and the surface conditions all affect the pattern. In slow motion, a falling drop can create a tiny crown-shaped splash. A ring of water rises. Small droplets may break away. Then the surface collapses back. A vertical jet can rise for a moment. Then it falls. All of this happens quickly. But when many drops fall, the fast details blend into a peaceful texture. A puddle in the rain is a small laboratory of waves. Impact, splash, ripple, interference, damping, return. Each drop disturbs the water. The water responds, then settles, only to be disturbed again. This is one reason rainy surfaces are visually soothing. They are full of repeated motion. But the repetition is not mechanical. It is natural, irregular, soft. The eye can follow for a while, then let go. Chapter 15, Rain in the Ground. Some rain becomes puddles. Some flows into drains, streams, and rivers. Some soaks into the soil. The way rain enters the ground depends on the surface. Dry soil can absorb water, but not always quickly. Soil has pores, tiny spaces between grains and organic matter. Water can move into these spaces through infiltration. If rain falls gently, much of it may soak in. If rain falls too heavily, the surface may not absorb it fast enough. Then water runs over the surface. This is runoff. Runoff can collect into streams. Streams join rivers. Rivers carry water back toward lakes and oceans. Water that soaks into ground may be taken up by plant roots. Some of it may move deeper and become groundwater. Groundwater can travel slowly through rock and sediment, very slowly, sometimes over years, decades, or even longer. Eventually, Groundwater may emerge again through springs, feed rivers, or return to the ocean. So even after rain touches the ground, the water continues moving. Some paths are fast, a gutter to a drain, a stream to a river to the sea. Some paths are slow, water through soil, water through roots, water through underground layers. The water cycle contains many speeds. A raindrop may spend a few seconds falling from a cloud, then years underground, or minutes on a leaf, or months in a lake, or centuries in ice. Water moves through reservoirs, atmosphere, ocean, cloud, river, soil, plant, glacier, groundwater, living body. Each reservoir holds water for a different length of time. Rain is one transition between them, from atmosphere to surface, from sky to earth. Chapter 16, Rain and Plants. Plants have a deep relationship with rain. Water enters the soil. Roots absorb it. It travels upward through the plant. It helps carry minerals. It supports photosynthesis. It fills cells and helps maintain structure. Some of the water eventually leaves the plant through tiny openings in leaves called stomata. This process is called transpiration. Water vapor leaves the plant and enters the air. Together, evaporation from surfaces and transpiration from plants are often called evapotranspiration. This is a long word, but the idea is simple. Water returns to the air not only from oceans and lakes, but also through living plants. Forests can contribute moisture to the atmosphere. In this way, rain supports life, and life helps return water to the sky. It is ecological. A rainy forest is not just receiving water. Leaves catch droplets, absorb. Stomata release vapor. The air becomes moist. Clouds may form again. This connection between plants and rain can be felt in the smell after rain. The scent of wet soil is partly related to compounds released from soil and microorganisms, and oils from plants that can be lifted into the air. The smell after rain is called petrichor. It is not a single simple thing, but a mixture of signals from earth, plants, and atmosphere. For many people, it is a comforting smell, a sign that dry ground has been touched by water. Physics, chemistry, biology, and memory all meet in that scent. Rain is never just falling water. It is connection between sky and soil, between atmosphere and roots, between sunlight and vapor, between clouds and life. Chapter 17, Rain, Rivers, and the Long Path Back to the Sea. After rain reaches the ground, some of it begins another kind of journey, not through the sky this time, but across the surface of the earth. A small drop lands on a stone, another lands on a leaf, another falls onto a patch of soil. Some water sinks downward, some waits in tiny hollows, some begins to move. At first, the movement may be almost invisible, a thin film of water sliding over rock, a narrow thread flowing along the edge of a path, a small trickle finding the lowest place nearby. Water naturally follows slopes. It does not need to know where it is going. It simply responds to the shape of the land, downward, around obstacles, into small channels, toward larger channels. Together they become a small stream. The stream joins another stream. The water gathers. It becomes a creek. And slowly, sometimes over great distances, the river carries water back toward a lake, a wetland, or the sea. This is one of the quiet ways gravity shapes landscapes. Rain falls from the sky. Then gravity pulls water across the land. Water also changes the land as it moves. It loosens grains of soil. It rounds stones. It carves channels. It deepens valleys. A single raindrop seems too small to shape anything. A drop, then another, a shower, a season. Valley. Water is soft but persistent. And again, it follows gravity. It carries pieces of the world with it. And in doing so, it helps write the shape of the land. This long path back to the sea is part of the same story as the drop on the window. The water that taps gently on glass may one day run through soil. It may join a stream. It may flow beneath a bridge. It may widen into a river. It may reach the ocean. And then with sunlight, it may rise again. The journey is circular, but every loop is different. Chapter 18, The Smell After Rain. Rain is not only something we see and hear, it is also something we smell. Many people know the scent that comes after rain, especially after a dry period. It is earthy, fresh, sometimes slightly sweet, sometimes mineral. This smell is often called petrichor. The word refers to the scent associated with rain falling on dry ground. The smell comes from several sources. Plants can release oils that settle into soil and stone during dry weather. When rain arrives, these compounds can be lifted into the air. There is also a compound called geosmin. Geosmin is produced by certain microorganisms in soil. Humans can detect it at very low concentrations. That is one reason smell after rain can seem so noticeable even when it is faint. When raindrops hit porous ground, they can trap tiny bubbles of air. Those bubbles rise and burst, releasing small aerosol particles into the air. These tiny particles can carry scents from soil, plants, and microbes. So the smell of rain is also a physical process. Impact, tiny bubbles, aerosols, airborne molecules, breath, memory. The scent after rain can feel emotionally powerful because it connects the atmosphere to the ground. The sky touches the soil. Dry dust becomes damp earth. Microbial life announces itself in the air. The landscape seems to wake up. This is one of the gentle beauties of rain. It makes invisible things noticeable. The moisture in the air, the chemistry of soil, the life beneath our feet, the small particles carried upward after a drop lands. A rainy smell is not magic, but like many things in nature, understanding the physics and chemistry does not make it less beautiful. It makes the beauty deeper. The scent after rain is the earth breathing upward, a quiet message from soil, water, plants, and air. Chapter 19, The Water Cycle. Now let us step back and see the whole cycle. The water cycle is the movement of water through earth systems. Water evaporates from oceans, lakes, rivers, soil, and plants. It enters the atmosphere as vapor. Air carries it. It cools. Clouds form. Droplets grow. Water returns to land and sea. Some flows across the surface. Some enters the ground. Some becomes ice. Some is taken up by living things. Some evaporates again. The cycle continues. There is no true beginning point. We can begin with the ocean, but the ocean is also where much water returns. We can begin with a cloud, but the cloud formed from vapor that came from somewhere else. It is a loop, a planetary loop powered mainly by the sun and shaped by gravity. The sun lifts water by evaporation. Gravity brings water back down. Sunlight and gravity work together in the water cycle. Turns. One gives energy for vapor to rise. Evaporation would be weak. Without gravity, rain would not fall, rivers would not flow downhill, and oceans would not sit in basins the way they do. The water cycle is therefore a quiet partnership between energy and gravity, heat and falling, rising and returning, invisible vapor and visible rain. The cycle also helps regulate climate. Water vapor carries heat. Clouds reflect sunlight and trap infrared radiation. The water cycle is woven into weather, climate, ecology, and geology. A single rainy evening is part of a planetary circulation. The drop on a window may once have been ocean. It may become soil moisture. It may enter a root. It may become vapor again. It may fall somewhere else years later. Water travels, slowly and quickly, locally and globally, always changing form, always returning. Chapter 20, Rain and the Planet's Balance. Rain helps Earth maintain balance. Not a perfect, unchanging balance. The planet is always changing. But rain is one of the processes that moves energy, water, minerals, and life through the system. Rain distributes fresh water across land. Without rain, many rivers would shrink, soils would dry, Forests would struggle. Freshwater lakes and wetlands would change. Rain connects the atmosphere to the surface. It brings water from sky to soil. It washes particles from the air. It cools surfaces. It feeds streams. It shapes landscapes. It contributes to erosion. It breaks down rock. It carries sediment. Mountains, rivers, plains, and coastlines all carry the marks of water moving under gravity. Rain is soft when it falls as individual drops. But over enough time, falling and flowing water can reshape continents. This is a powerful idea. Gentle processes can become immense when repeated over long times. A single raindrop is small. A storm is larger. A river system is larger still. 1,000,000 years of rain and runoff can cut through stone. Rain also participates in climate. Clouds can reflect sunlight back into space. Clouds can also trap heat radiating from Earth. Rain removes water from the atmosphere and returns it to surface. Rainfall patterns shape ecosystems. It exists partly because rain rarely arrives. Grasslands, forests, wetlands, and farms all depend on the timing, amount, and rhythm of rainfall. In this sense, rain is not just weather. It is geography. It is ecology. It is geology. It is part of the slow metabolism of Earth. Water rises. Clouds form. Rivers flow. Plants grow. Oceans receive. And the cycle begins again. Chapter 21. Rain on other worlds. The idea of rain can exist in other forms on other worlds. Precipitation means material falling from an atmosphere to a surface. On Earth, that material is often water. But on other planets and moons, different substances can play similar roles. On Titan, Saturn's large moon, there are lakes and seas of liquid methane and ethane. Titan has a thick atmosphere. Methane can evaporate, form clouds, and fall as rain. Not water rain, but methane rain. On Venus, high in the atmosphere, sulfuric acid droplets can form clouds. The surface of Venus is extremely hot, and the atmosphere is dense and harsh. The idea of rain there is very different from a gentle earth shower. On some giant planets, scientists study forms of precipitation that are exotic compared with Earth, under extreme pressures and temperatures. Strange atmospheric chemistry may produce unfamiliar kinds of falling material. The details depend on the world, but the general idea is powerful. If a world has an atmosphere, temperature differences, condensable substances, and gravity, then cycles of condensation and precipitation may occur. Rain is Earth's version of a more general planetary process. Material rises or evaporates. It condenses. It falls. It returns. The substances change. The temperatures change. The landscapes change. But the physics echoes. This perspective makes Earth's rain feel both ordinary and precious. Ordinary because it happens often. Precious because liquid water rain is part of what makes Earth habitable. It waters ecosystems. It feeds rivers. It shapes landscapes. It supports agriculture. It refreshes soil. When rain falls here, it is not just weather. It is part of Earth's living system. A soft sign of a planet where water can move freely between sea, air, land, and life. Chapter 22, Why Rain Feels Peaceful. Although this video is about physics, it is worth asking why rain so often feels peaceful. Part of the answer may be sound. Rain creates a broad, steady sound texture. The pattern is random enough that it does not become boring, but steady enough that it does not demand constant attention. It can mask sharper, more sudden noises. This masking effect can make an environment feel more private and calm. Rain also changes light. Clouds soften sunlight. The world becomes less visually intense. Colors deepen. Reflections appear on wet surfaces. Edges blur slightly. The atmosphere feels quieter. Rain changes smell. Wet soil, plants, stone, and pavement release familiar scents. Rain changes behavior. People slow down. Streets become less busy. The world seems to pause. Sound waves, scattered light, moist air, cooling surfaces. soft impacts. Human experience gives those conditions meaning. A rainy night can feel safe because we are indoors, sheltered from the water outside. Ocean. Inside, stillness. Outside, falling drops. Inside, warmth. The mind notices the boundary. Window glass becomes a gentle separator between movement and rest. This is why rain often appears in sleep sounds, meditation backgrounds, and quiet scenes. It is active enough to fill attention, soft enough to let attention go. It is a physics event that becomes an emotional atmosphere. Water falls, air vibrates, light scatters, the ground darkens, and the mind relaxes. Chapter 23, a gentle summary. Let us gather the story softly. Rain begins with water, but not as falling drops. Sunlight warms the ocean, lakes, soil, and plants. Water molecules gain energy and escape into the air as invisible vapor. The air becomes humid. Warm, moist air rises. As it rises, pressure decreases. The air expands. It cools. When it cools enough, water vapor begins to condense around tiny particles in the air. Clouds form. Clouds are made of tiny droplets or ice crystals suspended in air. Inside clouds, droplets can grow. They collide. They merge. Ice crystals may grow and melt as they fall. Eventually, some drops become heavy enough that gravity pulls them downward. As they fall, air resistance slows them. They reach terminal velocity. They do not accelerate forever. They fall through a cushioning atmosphere. They may be round, flattened, wobbling, splitting, or merging. They may land on leaves, windows, roofs, roads, rivers, lakes, or oceans. When drops strike surfaces, they create sound. When they strike water, they create ripples. When they enter soil, they feed roots and groundwater. When they flow downhill, they join streams and rivers. Eventually, much of the water returns to the ocean, and then with sunlight, some of it rises again. Rain is not an isolated event. It is one moment in the water cycle, a visible return, a downward passage in a larger loop, powered by the sun, shaped by gravity, carried by air, and woven into life. Chapter 24, Closing Reflection. Not all at once, not in a complicated way, just gently. A surface of ocean warmed by sunlight, invisible water molecules rising into the air, condensing, gathering, growing, merging, becoming heavy enough to fall, then gravity taking over. A drop begins to descend. It falls through air. The air pushes back. It changes shape. It glimmers. It lands. Maybe on a leaf, maybe on a roof, maybe in a puddle, maybe on the surface of a river already moving toward the sea. The drop is small, but the story is large. It includes sunlight, atmosphere, temperature, pressure, gravity, sound, plants, soil, rivers, oceans, and time. Rain is one of the Earth's ways of breathing. Water rises. Water returns. Clouds gather. Clouds release. The planet circulates its water slowly, endlessly, patiently. And tonight, if you are resting, you do not need to follow every detail. You can let the rain become simple again. A soft sound, a dark window, a quiet room, a gentle rhythm outside. The physics will still be there. In every drop, in every ripple, in every cloud, in every return to the sea. You can simply listen. Let the ideas soften. Let the rain fall. Let the water cycle. Continue somewhere beyond the window. And let yourself rest. Sleep well. If you enjoyed this calm journey through the physics of rain, you can return anytime for more gentle physics stories about gravity.